We'll talk a little bit about variables and operators, mathematical operators in Python. A variable is just a name of a location that stores some data. Here, the name value stores the number 2000, which is an integer, no decimal place. Interest rate stores a decimal point, which is called a floating point number in Python. The name is a string of characters, so its type is called string. We did not need to tell Python what type of number or value is being stored into a variable. It figures it out. This looks like an integer, so it stores the number as an integer. This is different from Java, where you have to tell the programming language which is explicitly typed, or you have to tell it as a programmer what type of data you're going to store into which variable. This is called duck typing, where if it looks like a duck and quacks like a duck, it must be a duck. This looks like an integer, so value must be an integer variable. So let me run this program, and it'll just print out the account and put the name on there, so account Peabody, value 2000. Let's calculate a new value for interest rates. Now, I don't need to make a new variable. I'm just going to type an expression, and the expression is going to be the same one that you know how to calculate interest rates. 1 plus, this will be the new value. And the way this works is Python looks at the right-hand side of the equation, calculates this, and stores that back into this variable called value. So let's also copy this print statement so we can see what it looks like. There we go. It tells us what the new interest rate is, the new value of the account. Now you notice that value now has a decimal place. Value, the variable, used to store an integer. Since Python realized that now that I'm multiplying it by a floating point number, it's going to turn value into a floating point number. So it does this for you, and it does it dynamically. Most of the time, you don't need to think about the type, but sometimes you do, like for example, in a for loop, the range and the for loop can really be only dealing with integers. Let's ask the user for a year and calculate the value after that year. So let's make a place where it asks, and the function is input. Let's say how many years. And it'll ask the user how many years, and it'll put that into the year variable. And let's just take a quick look at what year is. So let's run this. It's going to ask me how many years, and I'll say let's say 5 years, and I hit enter and it printed 5. Now you should be careful because input returns a string. So this isn't the number 5. This is a string of letters, well, characters, in this case, the number 5. So if I wanted to do something like the interest rate equation, but I'm going to take the exponent. So I'll raise this to the year. It's going to give me an error. This, by the way, is the exponent, which is double asterisk. It's not the up caret like you would expect, because that's reserved for something else. Let's go over here. Let's put in 5 years, and it'll give me an error. And it says, it shows me that this is a problem, and that it's saying that there's a difference, there's a trouble here between you're trying to do an exponent or power, and there's a trouble where there's a string in there. So we can convert between different types of variables. So let's convert this input to a string. So after we get the input, actually, let me do this all at once. I was going to make a new line where I say year is equal to the string. I'm sorry, to the float, but actually, let's call this an integer number of years, and we'll convert this input now is inside this function called int, which will convert it to an integer. Now everything should work out fine. Oh, I forgot to print out the answer. It didn't give me an error. And after 5 years, it'll tell me the interest. There it is. That's the value of the investment with after 5 years of interest. Okay, so we converted to an integer. So you can convert things to integers like, let me see, if I want to convert the value to of the investment into an integer, I can do int. If I wanted to convert something to a float, there's a function called float. You rarely need to do that. I'm not going to bother showing that. You can take, this is a floating point number being converted to an integer, and what I'll do is I'll just get rid of the decimal places and truncate it. So let's do the same thing again. And this converted this floating point number, which is what the value is. And this last print is I'm printing the integer of this value. So it just truncated this and just got rid of the decimal places. It didn't round up or it didn't round down. It didn't think about rounding at all. It just took all the decimal places away. Okay, there are a few things I should mention here. Python has very strong opinions on what your code should look like, and I'm going to be strict about that. Python wants variables to be lowercase. It is case sensitive. You can make an uppercase variable. In rare instances, it makes sense. But for the most part, you can make lowercase values. If you have 2 words, you're going to do an underscore between the 2 words. You're not going to do, let's say, camel caps where you have a big letter in the middle. You're not going to do cap case, which is capitalize everything. You're not going to do those. You're going to leave it Python like this. And you notice how I made spaces before and after the equal sign. You have to do that. I'm going to be picky about that. You have to have spaces between operators like this, so that way you're not jamming all this together. You're going to make it nice and a little bit more readable, and that's what their goal is. So you notice I have spaces everywhere here. And there's a Pythonic way of doing things, and this makes it so you can look at anybody's Python code and it just looks and feels like Python code, and you don't have to adjust your eyes to get used to some other way of doing things. It's a really nice thing about Python. Let's continue doing some more of this in a little bit.